Okay, Assalamu alaikum. I am Jahangir. Today I am going to discuss about Edexcel IGCSE Certificate in Physics. Unit 3, Chapter 2. The electromagnetic spectrum. What is electromagnetic spectrum? First we have to learn about electromagnetic wave. Electromagnetic wave, the wave which is produced by the combination of electric field and magnetic field, where electric and magnetic field are mutually perpendicular to the direction of propagation of the wave, is called electromagnetic wave. Here is the specification of the Edexcel specification. After finishing this chapter, we understand that light is a part of continuous electromagnetic spectrum which includes radio, microwave, infrared, visible, ultraviolet, X-ray, gamma ray radiations, and that all these waves travel at the same speed in free space. We can identify the order of electromagnetic spectrum in terms of the decreasing wavelength and increasing frequency, including the colors of the visible spectrum. Explain some of the uses of electromagnetic radiation, including radio waves, broadcasting and communications, microwaves, cooking and satellite transmission, infrared, heaters and night vision equipment, visible light, optical fiber and photography, ultraviolet fluorescent lamps, X-ray observing the internal structure of objects and material and medical applications, gamma rays sterilizing food and medical equipment, understand the detrimental effect of excess exposure of human body of the human body of to the human body to electromagnetic waves, including microwave internal heating of body tissue, infrared skin burns, ultraviolet damage surface to surface cell and blindness, gamma ray cancer and mutation, and describe the simple protective measures against the risks. So first we have to learn about electromagnetic spectrum. The electromagnetic spectrum is a continuous spectrum of waves which includes the visible spectrum. So gamma ray, X-ray, ultraviolet, visible, infrared, microwave, radio. So gamma ray has the maximum frequency and minimum wavelength, and gradually increases the wavelength and decreases the frequency. The electromagnetic spectrum is divided into 7 bands or 7 segments, which in order of decreasing wavelength are radio waves is the maximum wavelength, microwave, infrared wave, visible light, ultraviolet, X-ray, gamma rays. So longest wavelength is radio waves and shortest wavelength is gamma rays. So this is the serial of decreasing wavelength. So maximum wavelength is radio wave, then microwaves, then infrared, visible light, ultraviolet, X-ray, gamma rays. List in order of decreasing frequency and energy. Gamma rays has the highest frequency and highest energy, then X-ray, ultraviolet, visible light, infrared, microwaves, radio waves. So highest frequency to lowest frequency. Highest frequency is gamma rays and lowest frequency is radio waves. We know energy equal to hf. E is the energy, here f is the frequency. So energy is directly proportional to frequency. That's why if the electromagnetic wave has highest frequency, then it has greatest energy. Common properties of uh, electromagnetic waves. All electromagnetic waves, including visible light, have the following common properties. Number one, they transfer energy. They are all transverse wave. So, what is transverse wave? If the direction of vibration of the medium particle is perpendicular to the direction of propagation of the wave, is called transverse wave. We know electromagnetic wave is the wave which is produced by the combination of electric and magnetic field, while electric and magnetic field are mutually perpendicular to the direction of propagation of the wave. That's why all electromagnetic waves are transverse wave. They all travel at the same speed through a vacuum, about 3 into 10 to the power 8 meter per second. They can all be reflected, refracted, and diffracted. Question 1. Calculate the wavelength of the radio waves in frequency 100 megahertz. Capital M means mega. Mega means 10 to the power 6. So megahertz, if its speed is 3 into 10 to the power 8. 3 to 10 to the power 8 meter per second. We know there is a wave equation. Wave speed V equal to frequency F into wavelength lambda. So wavelength lambda equals to V divided by F. So 3 into 10 to the power 8 meter per second divided by 100 megahertz. So 3 into 10 to the power 8 meter per second divided by 1 into 10 to the power 8 hertz. So wavelength equal to 3 meters here. Wavelength is 3 meters. Because 3 into 10 to the power 8 meter per second, and here 1 into 10 to the power 8 hertz. So 10 to the power 8, 10 to the power 8 cancel. So 3 meter is the wavelength. Now question number 2. Calculate the frequency of a light waves of wavelength 0.0007 millimeter of speed 3 into 10 to the power 8 meter per second. We have to calculate the frequency here. Remember, we have to calculate the frequency. We know wave equation V equal to F into lambda. Here V is the speed of the sound wave or speed of the electromagnetic wave. F is the frequency and lambda is the wavelength. So F equal to V divided by lambda. Here V 3 into 10 to the power 8 meter per second divided by 0.0007 millimeter. So I have to convert this millimeter into meter by dividing 1000. then frequency equal to 4.29 10 to the power 14 hertz. Now complete the fill in the gaps. Highest frequency is gamma ray, gamma ray. So then X-ray, highest frequency is gamma ray, then X-ray, then ultraviolet, then visible light, infrared, microwaves, then radio waves. Radio is the lowest frequency, and longest wavelength is radio waves, then microwave, then infrared, visible light, ultraviolet, X-ray, then shortest wavelength is gamma. Greatest energy, we know energy is directly proportional to frequency. So gamma ray is the greatest energy, then X-ray, then ultraviolet, visible light, infrared, microwaves, and least energy is radio waves. Choose appropriate words to fill in the gaps below. The electromagnetic wave